and we are recording. So we're going to cover a new topic today. That's a object-oriented topic, and so you find this in object-oriented languages like Java, like C#. And this is the concept of exception handling. And so this says how to handle exceptions and validate data. And you might say, well, haven't we kind of been doing data validation a little bit right now? Like, as an example, if the number is negative, give them an error message. And the answer is yes, we've been using if statements and maybe loops and things like this to validate data so far. What exception handling is another tool to both validate data, just like an if-else statement, or if-else inside of a loop. But it does a little bit more than just validate data. Exception handling is a way to code your program in effort to keep it from crashing. And so right now, you could all think of your labs and how many times you've been coding your labs, and then you go to run your program, and out of nowhere, the program crashes, and it gives you what's called an exception. And I don't know if you read the exception, if you read the error message, it throws like a paragraph of text, maybe 3 paragraphs of text at you. And so a lot of students, in my observation, they want to close it as if that exception doesn't say anything. But it does, right? What that exception is, we'll talk about what an exception is. And today we talk about exception handling, which is, well, if the exception is causing your program to crash, exception handling is keeping your program from crashing. And so sometimes that can be done with like if-else's, and sometimes it can't, right? Sometimes there's no way to code an if-else or some sort of loop that will keep your program from crashing, and so you have to default to this technique called handling exceptions. It is worth noting, kind of off of the top, that not every program has to be written in a way that isn't allowed to crash. Like if you think of Microsoft Word, we've all been using Microsoft Word, and it can crash from time to time. And then what happens is you lose your data. And it does its best effort to try and recover that data because it's a pretty savvy piece of software. But at the end of the day, like Word can crash and you might lose your English paper and you have to retype it, and that's the consequence of Word crashing. And so some applications are just allowed to crash, and the application developers and the managers make that decision. Like we're not able to, in every case, keep this software from crashing, and it is just okay. There's going to be a consequence to that, and that's just okay. So some software projects are just allowed to crash, and that's what it is. Okay. Other software projects are far more critical to keep it running. For example, something that comes to mind is the healthcare industry. And I don't know if any of you have family in the healthcare industry, but I do. I have family that are family members that are nurses. And what's interesting about nursing, especially during COVID, is they're doing more remote monitoring of patients now than ever, right? So remote monitoring of patients in hospitals is more common now than it's ever been in history. Okay, so when you have a piece of software that's monitoring a patient's vital status, whether they're living or they're going into cardiac arrest, okay, that software cannot crash. Okay, that's critical to someone's life to keep that software running. Okay, so just off of the top here, it's just an interesting note that we're going to be talking about techniques to stop software from crashing. Okay, some software projects are very critical down to the life and death of someone to keep them running. Other software projects, when you're talking about software that's controlling rockets, as they do in like SpaceX, right? SpaceX has software that is monitoring all this environment conditions, blaster rotation, blah blah blah. Okay, you know how much money is in a rocket, right? You cannot have software crashing when you're launching a rocket, or in SpaceX's case, trying to land a rocket. Okay, because there are millions and millions and millions of dollars that are at stake. And so again, I just find it interesting because I've had graduates come back to me and say, you know what, I work with Java and I work at the United States Postal Service, USPS, right? We all know USPS, they deliver the mail, right? I work on writing software for USPS, and we do everything with if-else statements and for loops. We do not handle the exceptions in our software. When the program crashes, we might log a reason like why it crashed. We might write that to some sort of system log or some sort of database, and we just make a note that it crashes, and then we reboot the application and we keep going. Right? So as me and my role and just my personal evolution and growth of understanding is I just find that interesting, is that anytime you study object-oriented programming, you're going to study exception handling. Okay, it is the object-oriented approach to handling exceptions, which are, and all an exception is kind of a runtime error that crashes the program. But not all software implement this. Yeah.
Does poor handling of exceptions, does that leave the program up for exploitation? Like if I'm like a good developer and I know 9 out of 10 times this should crash, is there a way for me to like reverse engineer, I guess, get into their program? If I know it should be crashing here.
Yeah, so let me make sure I understand the question so I can answer it. So the question is like, if I don't code good exception handling, does that make it like open to hacks, so to speak?
Yeah, could I get in there and then like reverse that and then cause it to crash?
If as a user, I wouldn't say as a developer you have more access to that because you need access to the source code. You know what I mean? So as a developer, but most of the times when you're talking about exploiting software, you're talking about doing it from a user point of view. And so, potentially from that avenue.
I'm trying to catch that before it, I guess, tries to handle the exception.
Yeah, and so, let's take a look, and maybe that will come more apparent as we start to use this. So you guys have seen exceptions before. And so if I show kind of a common exception, you've all seen this exception where you've got something hard-coded into your program like this that's going to read the text property of a text box, convert that to an integer, and store that in an integer. And if I run this without debugging, and I give it an integer, it's happy. Program does not crash. But if I don't give it an integer, this is what happens. You get an error message that says unhandled exception has occurred in your application. So first off, the language actually means something, right? Up until today, you just knew that it was a crash. But unhandled exception means that an error occurred at runtime. So the program is running. An error occurred that was not handled. And we're going to learn how to handle an exception. When we handle the exception, it stops it from crashing. And so we're going to learn that exceptions can occur. They can occur really anywhere in your code. Exceptions can occur anywhere in your code. And it tells us a little bit about the exception. Input string was not in a correct format. So the string, what is the string? The string is the 1.5. It is a string because it's in a text box. It was not in the correct format because it expected a whole number, but it received a floating point number. If you click on details, you could see the type of exception right here. This is called a format exception. Kind of makes sense. The format of the string is not correct, right? So this is actually our type, our data type. So exceptions are objects. That's why I covered the classes and objects section first before I covered exceptions. Exceptions are objects, and therefore they are types. Right? Format exception is a type of exception. If you scroll over, so the type is format exception, the error message, input string was not in a correct format. You can kind of dig into this, and it says there's this method here called string to number, and then number.parseInt32. When you kind of scroll, I always just scroll over and it says line 22. It'll even give you a line number. So here's line 22. So how can you stop this from crashing? Because right now, when I run this, of course, this is what we have is a crash. Of course, if the end user saw this, it would stop the program from running, and they'd have to relaunch it, just like you would have to relaunch Word. So how do we handle this exception? Well, there's a couple of not too difficult concepts. And the first concept is, okay, what you do is you put the code that can potentially cause the exception inside of a try block. So we saw that this is the line that's causing the problem. So we're just going to wrap it inside of a try. So that's step one. Step one, put the problematic code inside of a try block. So step one is that. Step two, handle the exception inside of the catch block. So if this code causes an exception to occur, line 26 would cause the exception to occur. it would then go into line 28 and look for the type. Remember the type we said was format exception. And see if the type matches, right? Since it threw a format exception and line 28 catches a format exception, the types match. And since the types match, you can put your response to the exception here. And so basically, this catch block is going to run instead of your program crashing. And so what are we going to do here? Well, what's common? It is common when you have something that happens when an exception occurs, to log the exception. And so inside of Windows, like computer management. Inside of computer management, there's, let's see if I can find my logs. So inside of Event Viewer, there are logs in your Event Viewer that talk about things that are going on in your system, in your Windows system, including the applications that are running. Okay, so you can write some C# code to kind of put in a log. Okay, I'm just saying, like in a real world application, it's kind of common to log the exceptions just so you can look at the logs later on and see what's happening with your software. How often are these things happening? But it's also common, as the slide here, you can use this to validate data. And so just how we could use an if-else to validate data, you can use a try-catch. And so instead of wrapping this in an if-else kind of thing, if the text box is null or if it's a double, what have you, we've been doing that for a while. You could just put the label results. And we'll just, label result.text equals. Now there is, using this exception object, there is kind of a default message because it's a format exception. What this does is it provides that default message that the developer was looking at, and it provides it to the end user. So if I actually look at what this message property is of this exception object, right? So if I put this, input string was not in a correct format. Do you think that communicates well to an end user at all? No, this message property is more for a developer's eyes. Okay? If you were going to provide a friendly error message to the user, you're probably not putting this message property. So maybe this message property goes into the log. That makes sense. But in the label, you might write your own error message. Please provide a whole number. Right? And you get the idea. Now, obviously, if this works, by the way, this is still kind of something I see some people struggling with. Why is number not accessible here?
Because it's within the try block.
We declared it inside of this block of code. Right? So this is called local scope. Remember when we talked about local scope? This variable is said to have local scope. It's local to the block of code that it's in. And so if we want this accessible outside the try block, of course we need to declare it outside the try block. Then we can assign it here. And then we'll give it a default value of 0. If they put a number into it, okay. Now, so what can happen? This try block can run, and it can run without a problem. If it runs without a problem, then it goes ahead here. Now, if it runs and there is a problem, this label result, we probably need a separate label, because here we don't have any sort of loop. And what's going to happen is it's going to run. I'm going to show you what happens if I put in a breakpoint. Let's throw the exception here. Start debugging, just to kind of show you the problem that I see with my own code. We put in that. We try to take the 1.5, convert it to an int, and store it in number. That doesn't work. This catch block catches the exception, puts an error message into the label, and yet it still outputs 02 string. So instead, it overwrites the label with the number 0. So it put an error message in the label, and then it puts the number 0 in the label. So what you could do is, instead of doing that here, you could just put the output of number, like if you just put that in the try block. And now, if it runs an exception, click, 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 catches, and it gives you the output. Please provide a whole number. And if I do just a whole number 1, we start it off at 0, converts it to 1, puts it in the label, and it doesn't run the catch block. Yeah, Josh.
So what's the difference between doing this and doing like an if statement that tests if the number is int or not?
That's a good question. So literally, 1 is considered an object-oriented solution. So the try-catch is considered object-oriented because exceptions are objects. And 1 is just a traditional error handling approach. And so both can solve the same problem. Both can solve the same problem. I guess what I haven't demonstrated yet is something that an exception can handle that an if-else might struggle to do. But there are a lot of use cases where both can solve them. So there's a rule of thumb that you'll read a lot. I'll get you, Vinny, 1 second. There's a rule of thumb. I just want to put this out here. Like when thinking about when do I use if-elses versus when do I use exceptions, one rule of thumb is that this try-catch block does have a little bit of a performance hindrance. Like it's not great for your application performance. And so, in my experience, I will tell you, when I first was writing try-catch blocks, it was not on the best computer. It was kind of on a slow computer. And I would notice when an exception would occur, like the thing would slow down. Like I would notice a performance difference on my slow computer. So try-catches are not the best for performance. And so the rule of thumb that you'll hear quite often, if an error occurs less than 75% of the time, you should use if-elses to handle the error. The error with what's considered to be traditional error handling. So traditional error handling just means if-elses. If the error occurs the other 25% of the time, right? Oh, I'm sorry. Did I say less? If it occurs more than 75% of the time. If the error occurs more than 75%, like what I'm trying to say, I don't know if I'm saying it clearly. I don't think I am. If it occurs frequently, 3 out of 4 times. If it occurs 3 out of 4 times, use if-elses. If it occurs infrequently, it is the exception. That's why they call it exception handling. If it occurs infrequently, if it occurs less than 25% of the time, here, if it occurs more than 25% of the time, there it is. If it occurs more than 25% of the time, you use if-else. If it occurs less than 25% of the time, you should use okay, so this is just one rule of thumb that I've read on more than one occasion about when to use which. Like if it happens frequently, you can use if-elses. If it happens less frequently, you could consider using error handling. Again, I will say some applications don't use exception handling at all. So it's kind of up to you or up to your boss on how you should handle the errors with if-elses or with exceptions. Okay. What exceptions are good at handling really well, though, that is a little bit harder to handle with if-else statements. For example, what we need to do is get into all the different kinds of exceptions, because right now we've looked at one exception, right? But for example, if you try to open a connection to a database, okay, now this is a real world thing that real world applications are going to do. They're going to work with databases. They just are. Okay, so your application's built in C#. There is a database running on a computer somewhere, and your application needs to essentially connect to that computer. That connection can be down for a million reasons. Okay, you might not have the right username and password. The cable between that 2 computers could be cut, right? The internet could be down at your location. Point is, there could be a million reasons why your application cannot connect to a database. Well, you're going to get a response in the form of an exception. So you're going to try and make a connection. That connection will not work. What's going to come back from the database is going to crash your software. That's a little bit harder. So to your question, Josh, like when do you need to use exceptions? There are scenarios that when you will make a request to a database and that database responds with an exception object. Like an exception object is going to come back to your application. A little bit harder to handle that in an if-else statement. Not to say that it can't be, but that's the idea. There's also times, here's another example. For anyone who used a computer in the 90s, you're going to relate to this. Every time here's another scenario that I was just going to, this is one kind of real world common scenario where you use try-catch blocks, opening a connection to a database. Here's another real world scenario. Your computer has resources, and one of those resources, hardware resources, is RAM. And so every time you run your software, every time your software runs, it uses RAM for its variables, right? In the 90s, applications would crash because your computer would run out of RAM. Does anybody remember that? Like running software, a couple people shake their head. Like you would be running software on your computer and your software would crash and say out of RAM. And so another common scenario, and it might not be RAM nowadays because we got 32 and 64 gigs of RAM, but when your software tries to use the computer hardware resources, and those resources aren't available. Thinking RAM, thinking hard drive, right? Again, hard drive space is full, but I'm imagining you go to write some information to a hard drive and the hard drive's full, right? You're going to get an error message back, and that's going to be in the form of an exception. Okay, so these are just kind of scenarios that I'm going to put out there that are very commonly handled by exception handling as compared to if-else statements. Not to say that they can't always be handled with if-elses. I'm just saying what's common. Yeah.
Sometimes, like when you use too much resource, like doesn't your computer just crash instead of like?
It slows down. I'm sure you've all seen that. Like, what happens if you don't reboot your laptop in 10 days?
Well, like the example that comes to my mind is like with video editing. When you go to like actually render a video, it tries to use like 100% of your CPU and GPU. And if you try to do something like really resource intensive while rendering a video, like sometimes it'll just blue screen.
It'll just
like it won't even give you an error. It'll just completely blue screen.
Your computer.
Yeah.
Yeah. So it's your operating system's job to handle that exception, right? So what happens is the application is crashing, and it's like, I'm out of resources, I need more resources. So it goes to the operating system, tries to get more resources from the operating system, but it's out. Your computer's out of resources. And so what happens when your operating system doesn't handle that exception is that you get the blue screen of death, right? So that's an example of exception bubbling. Right? It goes from one place to another trying to solve the problem, but it's ultimately unable to solve the problem. Okay. All right. I think it's a good, 15-minute break point. So let's go ahead and take a break, and then we're going to talk about more exception types, because we've only talked about one type of exception so far. Okay, so now that we have a basic understanding of exceptions and, they crash the program, and we've got these try-catch blocks to help us not crash the program, and we've seen one exception, now it's kind of like, well, what else is there? And this is really a pretty incomplete hierarchy. Again, this is why we study inheritance before we study exceptions, is because exceptions are classes, and classes have a hierarchy, and this kind of shows that, but I think a better visual, and for whatever it's worth, I can take a little snip and put this in Discord. This is a slightly more comprehensive class hierarchy of the exception classes that are out there. As we mentioned before, everything inherits from object. There is a parent of all the exception classes called exception underneath exception that has two children, system and application. System is basically all the built-in exceptions. Okay, and I don't even know the one that we did. Let me pull up my code. We did format exception. It's not even on this list. So certainly this is not a comprehensive list. It just shows you a little bit more of the hierarchy than what did on the slideshow. The big difference between system exception and application exception, the built-in stuff is under system, but they make this application exception because, as we will do in this chapter, you can create your own exception classes. And so if you create your own exception, your parent, it should be application exception. Okay, now some people are going to recommend application exception. Others say you could just go ahead and inherit from exception. Okay, it's kind of like potato in a lot. You might develop a strong opinion. I don't have one, but most things that I read say go ahead and inherit from application exception. So if you're creating your own class and you're inheriting from a parent exception class, let's go ahead and inherit from application. Then after that, it's like, okay, so you're seeing that there are a lot of exceptions that are built into C#. And then basically as you learn, you'll learn more about these exceptions and what they do. Right? Some of them are pretty obvious, like divide by zero exception. We could, for example, read a number, and then if we say int result is number divided by 0, maybe that should be a syntax error. It's not. It's going to be a runtime error in the form of an exception. This is going to cause your program to crash. If I run my program and I give it a whole number, you'll notice it crashes with an exception, and as you might have guessed, divide by 0 exception. Because of this hierarchy, you can kind of tell, just pasting that in Discord for the heck of it. Because of that hierarchy, you could tell that, that's a built-in exception. You could tell its hierarchy a little bit. How could we then handle it? Well, you can have multiple catch blocks. And so, since this catch handles a format exception on line 39, you could have another catch block that says you can't divide by 0. And so a try block, has the potential to throw multiple exception types. Therefore, you have the capability of catching multiple types of exceptions. And so divide by 0 is pretty straightforward. Format exception, we now understand if it's not in the right format, you're expecting one format, you get another. Here's another one worth covering kind of quick. We're storing this in an integer, and we know that integers have a range of acceptable values, right? Roughly -2 billion to +2 billion. If you put a whole number that's in that range, that's an acceptable value. We learned that in chapter 2. Okay, but what if I put some huge integer, I got some huge number, and I try and store that in an int? This is going to throw an overflow exception. So an overflow exception is just that. The number's too big or the number's too large to store in that data type, and you should probably store it in a different data type if that exception is going to happen frequently. Right? So how could we handle that? Well, we could do a catch overflow exception. And again, what error message do you provide to the user? That's really up to you. Is you want to be nice and friendly to the user, but that's an overflow exception. Yep.
Can you nest catch blocks?
No, we don't typically nest them. They're going to be outside of one another. Good question. But this is the convention. Let me go back here. What about this one? What about string name is null? And what if I try and take name dot to lower? Okay, we've got a null string. Now, it's been assigned a value. It just happens to be that value is null, which is a representation of nothingness. And then we're trying to use that null value and convert it to lowercase. And it doesn't really matter what we type. Instead, we're going to get null reference exception. So handle it, right? Null catch. Null reference exception EX. And again, you're noticing you can use these exception objects, or in some cases I'm not even using them, right? can't display null. Can't take a null value to lowercase. Again, going back here, I've demonstrated overflow exception. I've demonstrated null reference, divide by 0. You know, argument exception has its children. And so those are some of the common ones. Now, kind of going back to another resource, the Microsoft documentation, you know, some common exceptions are kind of out here. Again, I'll provide this link, and it talks about some exception types are not meant to be caught. And some, we're going to talk about how to manually throw exceptions. We can talk about how to do that. So some you don't want to catch, some you don't want to manually throw. So right now, all of the exceptions are occurring just by normal execution of the code. We're not causing an exception to be thrown. But there is a case where you might want an exception to be manually thrown. And so there's a keyword throw or throws where you can cause an exception to occur. And so these are just some other exception classes. You know, we've covered some of these. Index out of range exception is another common one. What's index out of range exception?
It has to do with like arrays, right?
It has to do with arrays. So if we say int numbers is new int with 10 numbers, their subscripts are 0 through 9. Therefore, if you try to access numbers sub 10, there is no number sub 10. Right? Because the subscripts are 0 through 9, so this is going to throw out of bounds. Index was outside of the bounds of the array. I'm sure you've seen this exception. So what's the takeaway here? Because I'm just kind of going through some various exceptions. The takeaway is the more you code in C#, the more comfortable you'll get with all the different kinds of exceptions that are out there. Right? You're not going to know them all today, but you're going to get a general understanding of what an exception is. It's this thing that crashes the program. There's a bunch of them built into C#. And so now that you're going to see these exceptions, and now you're going to know how to stop them from crashing the program. So sometimes you might go back and fix your source code. Like in this case, yeah, you can go fix the source code and it's not going to do that anymore. Right? Other times you might put a try catch in there because you're not going to want to change it. Benny?
Is it possible to get like 2 exceptions at once? So you get like an overflow exception as well as like one?
No, you'll just get one at a time.
Okay.
It is possible for one try block to potentially throw multiple exceptions, but you're only going to ever get one at a time.
It'll be whichever one happens first. Right?
Whichever one happens first. Yeah.
So, as far as exceptions goes, I mean, you can kind of mitigate some of this with like the booleans and if-else statements. Is this kind of
correct
geared towards when your programs get to start growing in size?
So again, so the question is kind of similar to Josh's early question, I think, which is when do you mitigate it with if-else statements and loops versus when do you use try-catch blocks? And the first rule of thumb I would use is this one here. This is my understanding, and you're going to read this in pretty much any textbook, which is it depends on how frequent you expect the error to occur. So if you expect the error to occur more than 25% of the time, a standard rule of thumb is to use if-else techniques. But if it occurs less than 25% of the time, or you can't figure out how to solve it with an if-else block, then you're going to want to use try-catches. And so again, the reality is that there's going to be these conditions where your software is crashing, And you might try and solve it with an if-else block, and you're just unable to. But it's giving you this exception object. It's saying, this is your exception object, and so you might be able to much easier handle it with this.
So I saw in the diagram you had, there was a COM exception, so I'm guessing that when your program has to communicate with other files or maybe a device, that's when you're definitely going to use an exception as opposed to... Exactly. So again, I do think that there are situations, exactly what you said, when you're communicating with other devices or system resources outside of your software's code, and you're trying to make a connection, you're trying to use some other resource, and that resource isn't available, and you're going to receive an exception from that resource. And it's like, okay, my program is crashing because the database is down. I don't want my program to crash because the database is down. And it's giving me this exception object, so let me handle that. Yeah.
Can you give us an example of, and maybe you already did, but an example of like a 25% rule, like what happens if it's more than 25%, less than 25%? Is there an example of that you could give? Like,
sure. Well, okay, let's just take it back. That's a good question. So let's take it back to like the first thing that we did where int number equals convert to int text box. And so the question becomes, okay, this could throw an exception. And so the question you ask yourself is, okay, so we're expecting a whole number here, and so the user's going to put in a number. How often do we expect them to not give us a whole number? And so it's a discussion. Is this happening all the time? Is it not happening all the time? Mm-hmm. Maybe you need to figure out how often it's happening so you log the problem.
Yeah, I was just about to say.
Yeah, so maybe you got to figure out how often this problem is occurring. And it might be a discussion between developers and managers, and you just got to assess how often is this condition happening. Mm-hmm. And if you're thinking it's happening frequently, then it's probably better off. And why is that? Why is it better off handling it with an if-else statement? And the answer is performance. Yeah. Like, these just perform a little bit better than exception handling. Does that kind of answer your...
Yes, yeah, no, absolutely.
Wonderful.
Yeah.
Wonderful. Yeah, Amel.
So you were starting to build a bunch of catch blocks, and could you wrap all that up into a method?
Yeah.
Okay.
Yeah. Oh, beautiful question. So let's do that. All right. So here's a button click, and here's my code that's crashing something. Amel says, and this is going to help you on your labs. Can you wrap this into a method? Which, if I undo this, you might remember I've showed this before. You can highlight a bunch of code. I'm just going to highlight all my stuff here, and I'm going to right click. Thank you. Quick actions. My wife tells me this all the time. Can you get the ketchup for me? Yeah, I'll open the fridge. Where's the ketchup? I don't see the ketchup. It's in the back. It's not in the back. I can't find the ketchup. Where's the ketchup? Is the ketchup in here? She goes, yeah, it's in front of your face. That is me. The ketchup's in my face, and I can't find it. So quick action is what I'm looking for. It's
second option.
Aha! Here, extract method, and so here puts all that code into a method for me, and it lets you name the method, do something. Oops. When it first does that, I'm going to do that one more time. Right click, refactoring, extract method, click this button, and it lets you type right away, do something. Okay. Now, I'm going to clean this up a little bit because this is actually overly complex for what I want to demonstrate. Okay, so now we got a method call. And that method call does something. And I'm going to put my int number equals convert 2n32 text number.text. You know that that line can throw an exception. Okay, so what you can do is do a try catch, and I demonstrated an overflow exception EX. Basically, this 2n32 method can throw an overflow exception, and I can handle it right here. Label result.text equals ex.message. That's cool. Okay, so if a method throws an exception, it can be caught in that method. And so just to demonstrate that, however, it's also kind of common. Remember, the overflow exception is the big number one. However, you can also let the exception bubble up to the calling method. What's the calling method? Button submit click is the method that calls do something. So what happened is the exception is thrown and it looks for a try catch block inside of do something. But if do something doesn't have a try catch block, you can wrap the method call try. And because you know do something throws an exception, which we just said overflow exception EX, this is also valid. And so if do something doesn't have the try and catch block in it, the exception is passed up to the calling method, or that's bubbles up. It bubbles up, and you can handle it here. Ultimately, if the exception isn't handled, you know what happens, it crashes, right? So if there is no try catch block, it crashes, but this is called exception bubbling, right? It bubbles up to the calling method, right? And this would work the same way as you would anticipate. You put the big number in there, and there you go. So the question was, can this all work with methods? The answer is yes. And in fact, that's what this toInt32 method does. That toInt32 method, that's where the exception is occurring at. The exception is occurring inside of this method call. This method, toInt32, it doesn't handle the exception. Instead, it lets up to us, the users of the method, decide if we want to handle that exception, right? So when you're designing classes, that's typically what you do, right? You don't put the try catch blocks in the methods. Most of the time, you surround them around the method calls, right? That way, whoever is using your methods, they get to decide if they handle the exception or not. Right? Because again, not all applications use this stuff. So that's a really good question. And I'll take it one more layer deep, and I'll have this method call, method A, and then I'll have method A call B. Of course, these are made private, so I'll just stick with that. A calls B, B calls C. Okay, so your button click calls A calls B calls C, and C throws the exception. All I'm showing is that that exception bubbling still happens here, right? So C is causing the exception to. This fires the exception, launches the exception. The exception can occur here. Button click calls A calls B, B calls C, C throws the exception, and we don't catch it all the way back until here. We try the method call A. Now I'm going to show when do we do this exception EX. This is overflow exception. Ultimately, a method looks for a try-catch block. If it finds the try-catch block, it handles the exception. If not, it bubbles it up the call stack. The call stack is just methods that are calling each other. One calling the other, calling the other. So exceptions bubble up through the call stack. It's like a bunch of terms you've never heard before today. Possibly. If you don't, like let's take a look at this. By the way, if you don't ultimately handle that exception, and we just call method A here, I want to show you what it looks like. Because again, this error message gives us a little bit of detail. Here's the call stack. Let's see. We can see that C calls B calls A, which is called by button click. Now I don't know if you remember, like I remember, but one of the graduates talked about tracing code through the call stack and how a lot of his day is spent trying to find these errors that happen somewhere in the code and having to dig through all this pre-written code to find out the one line, which is line 46. And why is line 46 even running? How is it possible that that line of code is even being executed? Well, it was called by line 38, which was called by line 32, which was called by line 23. Right? So this call stack concept, right, where you're like, hey, users are reporting this bug. I see that for some reason this line's executed in my code and I have no idea how that's even running. Right? Understanding this concept of call stack is useful. It's useful. It's also worth noting here that because we've studied classes and objects, we know that a child object can be stored in a parent object, like animal A equals new dog. We've done that. We've stored children in their parent reference objects, right? So if a overflow exception occurs, it could be technically caught by the exception object. Why would you want to do that versus why wouldn't you want to do that's what we need to talk about. But if I take a look at this, and it's really the same, it still gives you the same message property. So, an argument could be made like, why don't you just, since everything inherits from exception, why don't you just do this for all of your exceptions? And let's do another one, right? So we just did a overflow exception. Let's do a format exception. Well, there you go. The reason is if all you're doing is giving the message, that's cool, and this works. But like, what if your application needs to behave differently? Then you're going to need different lines of code in different catch blocks. You see what I'm saying? Because of, what is this called, where a reference object behaves differently based on the child that it references? What is that fun word? A parent object behaves differently based on the child that it references called, it's a fun word. I don't say there's many of these words are fun.
Oh,
polymorphism. right? This is an example of polymorphic behavior. Okay, where one line of code looks like one line of code, like it would behave the same way every time, right? This line of code, to the untrained eye, looks like this would just do the same thing every time, but it doesn't. I just demonstrate that that one line of code can behave differently based on the child object that's passed into the parent. Okay, but why is this, and when can this be a downfall? Well, what if you wanted to give, what if you didn't want the generic message? What if you wanted to, provide something that's not built in, like you must provide a whole number? I would argue that a lot of the times your language can be more user-friendly than the built-in message. Okay, and so now I've got a format exception, and now I'm going to catch an overflow exception because I think I can provide a more specific error message that says, your number range must be between -2 bill and +2 bill. I think that might be a little bit more user-friendly than your number's too big or small. Yeah.
Does this mean you also, in regards to exceptions, and you can put in different methods to keep from throwing the exceptions? Like you can put in an error message plus either like reset a form.
Yes.
Or,
yeah, you could do a bunch of behaviors in here. You can reset the form. So, this is not the only thing that you can do a bunch of things. So like this catch block, it could do 10 various things. It could do 10 things. This one could do 5 various things. Reset the form and close the connections and blah, blah, blah. Okay? Now, looking at our hierarchy, remind me, does this go from generic to specific top down, or does it go from specific to generic?
Get more generic to go up.
It gets more generic as you go up,
Yeah.
right? The down the hierarchy you go, the more specific you go. Right?
Exception can be anything.
Exception can be anything, so it's more generic. Notice how my more generic exception is beneath my more specific exceptions. Because what happens if an exception is thrown, it's going to go top to bottom. It's going to look for the more specific exceptions first, and if they match, then they run. Otherwise, it'll be caught by the generic exception. Okay? This is a requirement. If you have multiple catch blocks, they have to go from specific, meaning lower in the hierarchy first, specific to generic. Right? So watch what happens if I take this exception block and move it to the top. I get this. This says something about what I just said.
So it actually runs top to bottom in this case.
The catch blocks run top to bottom, and for that reason they have to be structured from specific to generic, meaning lower in the hierarchy first to higher in the hierarchy later. We've covered a lot of ground this morning. This is good stuff. Yes?
Okay, so could you always code these in the form, or could you code them in the class level that way, so they can also inherit those?
That goes back to your question. Yes, they could be coded in the class. So let's do that, right? That just goes back. It's the same answer to your method question.
Oh, okay.
It's the same answer. You can code them in the class, but most of the time you don't, because you want the users of the class to do the try-catch. You with me? So let's just throw a class in here since the question was asked, and I'll add a class called dog. and I'll do a name, and all right, so my dog has a name, and I got a constructor to create the dog. And let's say that our set block I'll change this just real quick to use the instance field. I'll just do the get return name set. Let's say for whatever reason you were doing a set block and you said int num equals 1 divided by 0. And this is actually smart enough to know can't divide by 0. I'm going to get this to work. Okay. This is going to throw an exception when you go to set a name. That's going to be a divide by 0 exception. So whenever you call the name property to set the name, exception is going to be thrown, demonstrated as here. Let's go ahead and in my C, dog, my dog equals new dog. My dog dot name equals Rover. Line 59 calls the name set block. The name set block divides by 0 for unknown reasons. Causes an exception, causes it to crash. Whenever I click the button, I need a no arg constructor on dog. I've got a parameterized constructor. Doesn't like that. I need a no arg constructor. Now I can create my dog and set its name. Click the button. Attempt to divide by 0. Wait a tick. How did that work? If you remember, I still have a try catch that catches exception EX. A calls B, B calls C, C instantiates my dog. In the class, technically, line 31 throws the exception. 31 goes up to 59. 59 goes to 53, goes to here, goes to here. Did you follow that flow? It was a lot of steps. Is it worth a breakpoint or no?
Yes, please.
Debug, start debugging. Click the button. A calls B, B calls C, C creates the dog.
Why do we need A and B?
No reason besides that whole concept of the stack, the call stack. Understanding that ultimately this name property, if I can step into it, a lot of times you're going to get a message like this. C calls B calls A, right? So an exception occurs. So functionally, it does nothing. Does that answer your question, Vinny? We don't need those method calls. I just use it for demonstration. And there it's caught by the exception general. Again, that's the parent. We've got some polymorphic behavior going on here because we're taking a child, which is divide by 0 class, and storing it in a parent, which is the exception class. And there we didn't crash the program. Does that answer your question, Emil?
Yeah.
Kind of the same answer as before. You just let it bubble. Let it bubble up. The last thing here, and we don't really use this in this class much, although I do believe it is used more in the real world. I wish I didn't say that so frequently in this class, because sometimes it's the matter of the nature. I don't know. It's the nature of the beast is what I'm trying to say. There's one more keyword, try and catch. There's one more keyword that's pretty commonly used, which is finally. The finally block will run regardless of an exception being thrown. So the try catch may or may not throw an exception. The try block may or may not throw an exception. If it does throw an exception, one of these catch blocks should catch it. If you coded it properly. By the way, what happens if an exception is thrown and none of these catch blocks match? It'll still crash. Your program will still crash. So in theory, your catch blocks should catch it, but it's not guaranteed to. Or your try block could run and not throw an exception. Okay? But regardless of an exception being thrown or not, there is a finally block here that runs regardless. And so a lot of times you're going to do cleanup tasks, such as, again, and we will do this in this class when we work with databases, right? Very commonly in a try block, I'm going to say you open a connection to a database. Okay, we will do this in this class. We're just not there quite yet. Open a connection to a database, and then here you have a catch simply to say database not open. You provide an error message, you log it, etc. Finally, you could, and this is what is a cleanup task, close the connection to the database. Right? So could you not put this cleanup task inside of a catch block? Yeah, I guess you could. However, it's not guaranteed. Why is this important? It's not guaranteed to be caught. And so regardless, like if an exception is thrown and a catch isn't executed, this finally still runs. And so like what you want to do is you want to guarantee that your application is cleaned up and it's not leaving resources hanging. Open connections to a database is a hanging resource. Why is that a problem? Because databases might only allow so many inbound connections. And so you don't want to leave your resources hanging. We talked about earlier about, the longer your laptop is powered on, it slows down over time. Why is that? Just because applications are not returning the RAM back to the operating system. Resources are left hanging. And that's called a memory leak. Okay, you don't want to leave resources hanging. And so this finally block is kind of a block of code that you can put in there that's guaranteed to run no matter what, that will close connections is the theory there. Yeah.
Couldn't you just use a method to do the same thing and have it be guaranteed?
No. Here's why you can't. Let's just say your cleanup tasks are here. Okay, so I'm going to make a method. And this does stuff. You with me?
I'm with you.
All right. So this method cleans up stuff. Cleans up stuff. Okay, so where would you put this? Okay, so I want to do this method call. Maybe here. Maybe here. maybe here. The first thing I'm sure you see it, is clearly repetitive. So I don't like that. But it could work. So if A runs without problem, it runs cleanup. And you kind of have this catch-all here, this catch-all exception, because exception is the parent of all exception classes. I suppose this could be done. I answered no. I don't know that you want to do it that way. I don't know that you want to do it that way. Possible, yes. Desirable, no. Plus, I always feel like there's a scenario that I'm not thinking about. But it seems to me that this is your catch-all. So what's better than this? What's better than this is this is what the finally block is for. You just kind of come down here, you say finally, clean up. Less repetitive code. Okay, I'm going to stop lecturing here because it's been a long lecture. There is more to cover in this chapter. Specifically, what we're going to cover on Monday of next week is making your own exceptions and why you would do that and how it's done.